So if we're trying to simplify radicals, first off, what you want to think about is something like this, the square root of 49. Well, what multiplies together to give me 49? 7. So we all know this is just 7 times 7. So simply, 7 times 7 gives me 49. I pull out a group of size 2. In other words, a 7 times a 7, they come out and just become a 7 outside of my square root, as you all know. By the way, we don't write it, but we assume that there's a little 2 there, and that tells us how many 7s do I need to be able to pull them out. So this just turns into a 7. Now, something a little bit different, something like this. If you have the square root of 1 over 4 plus the square root of 1 over 9, how do I deal with that? Well, what multiplies by itself to give me 1 over 4? 1 over 2. 1 over 2 times 1 over 2, right? And the other one is like 1 over 3 times 1 over 3. So when you pull out these two 1/2s and these two 1/3, I get 1/2 plus 1/3. By the way, it's a good thing to know that there's another way to do that as well. I could have also said, oh, you know what, I'm just going to apply this to the top and the bottom separately. So root 1 over root 4 plus root 1 over root 9 would just lead me to, well, the square root of 1 is just 1, square root of 4 is just 2, plus the square root of 1 is just 1, square root of 9 is 3. So you get to the same spot either way. At this point, now I would want to come up with a common denominator so I can actually add these things. So this one gets multiplied by 3 over 3, and this one by 2 over 2. Good. So you get 3 over 6 plus 2 over 6, which simply is 5 over 6. And we're good. Now, they get a little more interesting when something like this happens. Square root of 75. Well, the square root of 75, if you were to factor that down, and I write it as, say, 75 can be multiplied, you can get there by multiplying 25 and 3. 25, you notice, is a perfect square, so I could write it as the square root of 25 times 3. The 25, if I just take the square root of that, what do I get? 5, and I'm left with a root 3 inside of it. Or, if you want, you can break it down even further and think 25 is just 5 times 5, so I could write root 75 as the square root of 3 times 5 times 5. Then I'm thinking, oh, I need to pull out a group of something that has 2 in it. The 5s, there are 2 of them, so I pull those out. I'm left with 5 root 3. Either way. Then, let's do one more question here. So, something like this. Negative 12 multiplied by root 96. Well, 96, what multiplies together to give me 96? Say it again. 48 and 2. Sounds good. Now, what multiplies to give me 48? Sure, we can go with 6 and 8. The 6, 3 and 2, the 8, 4 and 2, and the 4 is 2 and 2. Okay, so we've factored this thing down a whole bunch, and so you could write this as negative 12 multiplied by the square root of, and then anything that ends the bottom here, all that stuff, whoops, is inside there, right? So I've got 1, 2, 3, 4, 5 2s, and a 3. Right? So, at this point I think, well, I need to pull out that group of 2 2s, pull out this group of 2 2s, and that's it. That's all I can pull out. So this is going to be negative 12, and then when I pull out those group of 2 2s, they were multiplying each other inside, so they keep multiplying each other out here. So I've got 2 times 2, and then root 6 left over, the 2 times the 3. So that's simply going to be negative, and you have negative 12 multiplied by the 4 here. You multiply the coefficients together, so you're going to end up with negative 48 root 6. And that's as far as we can take it.